Normalizing a line is just a fancy way of saying we're going to scale the line so it has a length of 1. The word normal comes to us from mathematics, where we often say that a line or an arrow that has a length of 1 is normal. Now, of course, this doesn't mean that other lines are somehow abnormal. It's just the way the language developed. So to normalize a line, we scale it so it has a length of exactly 1. This is a really useful thing to do because it's very easy to scale a normalized line to any length we want. Here's a little coordinate system, and suppose I have this line. Now I don't know how long this line is. It could be 37 pixels long, 180 pixels, I don't know. But I do know that if I want to make it twice as big, I only have to multiply the x and y values by 2, and I'll get a line that's twice as big. If I want to take my original line and make it half as big, I just multiply the x and y values by a half, and I get a line that's half as big. But suppose I wanted to scale this line to some exact length, like 137 pixels long. Now I know that all I have to do is multiply the x and y values by something, but I don't know what that something is. Because I don't know how long this line was originally, I don't know whether I want to make it bigger or smaller to get to 137, and even if I did know that, I wouldn't know by how much to scale it. By normalizing the line first, we completely eliminate that problem, and it becomes easy to draw a line in this direction of any length we want. So let me show you how to normalize a line. It's really easy. Here's my coordinate system, and I'm going to draw this line, and I want to normalize it. As before, I can either think of this as the line itself, or I can just think of the point at the end of the line, because I know the other end point is at 0, 0. So let's say that this is at px, py. Those are just the coordinates of this point, and now I want to normalize the line from the origin to px, py. In this diagram, because everything is blown way up, I'll draw a circle of radius 1. So this circle is only 1 pixel in radius. We're not going to draw this little circle in our picture. I'm just showing it here so we can see what 1 pixel of distance looks like. So now I can draw a line from the origin towards px, py that's just 1 pixel long. And here it is in thick green. The endpoint of this line is the endpoint of the normalized line because the circle has radius 1, so this green line has a distance of 1 from the origin to the green circle. I'll call these coordinates Npx, Npy. You can, of course, call them anything you want. They're just variables. But when I make a normalized version of a line or a point, I often stick an n in front to remind myself it's the normalized version. So how do we find Npx and Npy from the original points px and py? There's really just 2 steps. The first step is to find the distance from the origin to the original point px, py, and I'll call that d. For the moment, don't worry about how we find d. Just assume that we can find this distance. As far as the normalized point goes, we know that the distance from the origin to the green point is just 1. The first thing we need to do is to find d. And this is such a common thing that we need to do. Processing gives us a built-in function call to do exactly that. Here it is. It's called mag, which is short for magnitude or length. Mag of px and py gives us the magnitude or length of the line from the origin to px, py. So we don't have to worry about the mathematics of this or where it comes from. We just call mag and we get back that distance. Now to find Npx and Npy, we just take the coordinates of px and py and divide them by that distance. So the normalized px is just px over d. The normalized py is just py over d. These coordinates, Npx and Npy, just the original px and py divided by d, will be a length of 1 from the origin. If you like doing little bits of math and you remember some geometry and some algebra, you can prove to yourself that this all makes sense. If that's not your thing, don't worry about it. This is a recipe and it always works. Well, not always. I'm skimping on one thing. Look in the last 2 lines. I'm dividing by d. Suppose that px and py both have the value 0. Which they can. It's just a line that doesn't go anywhere. Starts at 0, 0, and it ends at 0, 0. The magnitude of that line is 0. It has no length. So D is 0. If in the bottom two lines I try to divide by D when D is 0, processing will stop. It will crash. You'll get an error message and your program will stop running. The problem is that mathematically you can't divide by 0. Any number divided by 0 is infinity, and processing doesn't have a way of really handling infinity very well. Now, this isn't unique to processing. All programming languages will freak out if you try to divide by 0. They freak out in different ways, but no programming language likes it when you divide by 0 because you generate infinity. Now, of course, we don't want our programs to crash, and so somehow we have to avoid this. There are a bunch of different ways to prevent your program from crashing in this situation. Here's what I think of is the easiest way. I'll just put in a little test. I'll say if D is equal to 0, then I just set D to 1. I really could set it to anything. 1, -1, 1,000, anything that isn't 0. But I usually use 1. So suppose our input point px, py really was 0, 0, D was 0, and now D is 1. Then Npx, the norm to px, is just 0 over 1. Well, that's fine. That's just 0. And Npy is 0 over 1, which is just 0. And so everything is nice and clean. Any time in any program that you divide by a number, you're almost always going to want to have a check before that division to make sure you're not dividing by 0. What you do if the value is 0 depends on the nature of your program, but 99% of the time doing something like this, where we just set the value to 1, works perfectly well. These 4 lines now are the recipe for normalizing any line. So we start with px and py. They can be anything, anywhere on the screen. And we compute npx and npy, which is the point in the same direction as px and py, but 1 unit away from the origin. Now if I want a line from the origin in the direction of px and py that is, say, 137 units long, I just multiply npx and npy by 137. You'll often find when you're messing around with geometry to create a picture, it's easiest to normalize all of your lines and then scale them to the length you want. And to normalize a line, this is all it takes.